Okay, right about there. Hey y'all, my name is Nick. I'll be your SI for the summer semester. Today we're just going to do a basic review. I guess I can kind of introduce the topic of SI because I know that Calc 1 probably has a couple of freshmen in it at least. So some of you may not know. Some of you may be like dual enrollment students, but an SI is essentially a supplemental instruction leader. And what I do is I'm here not to give you answers or anything, but I'm here to assist you in any way I can. So this, you can view it as extra practice because higher level mathematics like Calc 1, where you're going to be introduced to differentiation, different techniques of differentiation, topics such as optimization, limits. This is the first time you're going to see a lot of these concepts. So we're going to start real slow and just review the basics. And I think that for those possible freshmen, the unknown, because I don't know how old you guys are, but if you don't know what SI is, you can view it as extra practice for any class that you're taking, and it is offered through the university for free. It's not worth extra credit or anything. It is just, I used to use it, and when I was taking Calc 1 for like, I would just go there and do homework in the session, and if I came across a concept I didn't quite understand, then I would ask a question about the concept. Because with more advanced math like calculus, you're going to want to start, and you really need to know the fundamentals for this class. Like first thing we'll talk about, I guess, we'll talk about logs, radicals, and trig identities, because I know that that tends to be the area that most people struggle with. So for starters, I'm just going to start at the bare basics. Natural log of x is just equal to log base e of x. So basically, if you see an ln, that's just a base e. And if you see just log of x, that is assumed to be of base 10, because that's just our number system is written in base 10. So if there is not one, it is assumed to be in base 10, unless you're a physicist, in which case log of x means that, but you guys don't have to worry about that. This will be very straightforward. So now just kind of review of what a log function is. I'm going to start with, you know what, I'm going to change colors because Khan Academy does it, and it seems to work for him. But here, we'll draw a graph here. So we've got an x and y plane, right? So exponential function, we'll just say something like y equals e to the x. So an exponential function like this, the contact point is going to be somewhere around here, like 2.7, right? And an exponential function, as we know, just goes on. This is going to have a asymptote on the y equals, let's think, 0. Yeah, it's going to be basically, it's limited by the x-axis. What that means is that this is going to continue and get infinitely small, which I'm not quite sure if Professor King has gotten into this, but an infinitesimal, that's like I'm sure a lot of you have probably at least been introduced to this format now. dx for e to the x, something like that, right? Just basically what this means is the derivative of e to the x. And normally, like, you can also see it in this form, which is dy dx. But this, since we already have y in terms of x, we just wrote it d e to the x over dx. Like, it's just basic mathematical notation. We'll get more into it later on in the semester, but for now, we're just gonna keep up with the basics. So the reason I even drew out this exponential function here is because if you know what an exponential function is, then you also know what a log is. So for example, a exponential function e to the x, the inverse of this is ln of x. Because what a natural log essentially is we're saying that log base e, and we'll say 0, because that's a really easy one to work with. No, we'll say 1. So this right here, we're basically saying e And if we'll say it equals 0, because anything to the 0th power is 1, right? So we're saying that the base raised to the power of the answer, or raised to this power, is going to give us the answer. So we know that e to the first power, or e to the 0th power, is going to give us 1. This is the answer. This is the power you're raising it to. This is the number that you're raising to that power. Just a quick, basic algebra review. If I'm going too fast or too slow, feel free to comment. Just let me know if there's anything specific you guys want to look at. I'm just kind of giving a general introduction for this course. So I figured that the one thing I noticed a lot of people lack in later classes in mathematics, like differential equations, calculus 2, is they don't really understand these fundamentals, which holds them back in differentiation, which is then going to cause problems later on down the road, like when you get to integration or differentiation in 3 dimensions instead of 2. But for now, we're just going to learn the basics so you guys can really have that grip on the fundamentals. So speaking of fundamentals, this is basically logs, right? So now this one I'm going to go over very briefly because I know that you have calculators that can do it, but we're going to cover radicals just because I want to. Because there's always one kid that has a question about radicals. So if I can get that kid to not ask that question, I call that a success. So square root 175, I'm sure a lot of you are like, okay, let me get out my calculator. But now that you're in a higher level math class, you're not going to be able to give us a decimal answer or anything like that. We're going to need a simplified radical as an expression. So the best way to do this, a lot of teachers say, is you find like a tree, like a lot of teachers will just do that method and that method, whatever. I'm not a fan of it. I use a little bit more of a straightforward method. So here's square root 175. This is a pretty easy example. It's one of my favorites because I like to think of it like cash, like $1.75. That's going to be 4 quarters and $1, 3 quarters and 75 cents. So that's going to be equal to 7 times 25 because 4 quarters plus 3 quarters, 7 quarters. So we can break this down, and I'll write out the tree just because nuance, but 7, 25. So 25, this is equal to square root of 7 times square root of 25. That is equal to that. So we know that we can simplify the square root of 25 to 5. So you'll get something that looks kind of like this. 5 root 7, because we have no need for the 5 to be under the square root since we can just break it apart like that. And that's a more general introduction to how I think you guys should start trying to think about approaching problems, because in lower level math classes, they kind of give you a layout to approach a problem, but once you get to calculus and Calc 2 or anything really above pre-calculus or trigonometry, you're going to have to start figuring out how to approach these problems in your own way. And my favorite way to do is just dissect it down to the bare bones, get the binary code, just adding and subtracting. That's essentially what all of mathematics is. And when you get to calculus 2, you'll understand what I mean by that. When you get infinite series, because basically that's how calculators multiply and do all that complex stuff, is with summations that just iterate addition. So if you're worried about this class, you can think about it in the most simple terms. You can think about it, the bigger concepts like inverse, like logarithms. What we're about to get into is trigonometry. This is a class that I SI'd for 2 semesters ago, and I have quite a useful trick for y'all, which I think everyone here will appreciate this. I mean, who here, feel free to comment, like flex. This is a moment that you guys can just, kind of show off, but who here has the entire unit circle memorized? Just like, I don't know, comment yes or something like that. Because otherwise this is just going to be me lecturing on a computer and I'll get bored. So who here, does anyone have the unit circle memorized? All right, there's one, good job. I see someone paid attention in trigonometry. Anyone else? All right. Okay, there's a no, so perfect. So those of you that memorize the unit circle, I'm going to show you why you're wrong for memorizing it and the reason that you didn't have to in the first place. For those of you that don't have it memorized, I'm going to show you guys how to draw a unit circle in about 5 minutes. And then if you do it 4 more times after this session, which I just used to give that to private tutoring students, I'd give them a couple of blank unit circles, and I'll get into it. I'll just less speak, more show. So that's not a great circle, but it doesn't really matter. Let's go there, there. All right, so this is a circle. So the first thing we're gonna do is we're gonna go, I like to start with, there are a few things you need to memorize. First of all, like you need to know the first 3 lines here to know everything else. So the first line is gonna be pi over 6. This is just blatant memorization. This shouldn't be too bad to recall. Pi over 4, and then pi over 3 for this line. Yeah. And this is 0, comma 2 pi, because if you start at 0 and then spin 360 degrees, you're gonna end back up at 0. Just real basic stuff. This, I'm assuming most of you have at least this quadrant memorized, so I'll just get right into it. So now these ones, the radical values and all that, like the sine and cosine values, right? Because we all know that we write coordinates as x, y, right? So x and y, we know that cosine is it's always positive. It's a, what's the word for it? Absolute function, I believe, or a positive function, something along the lines of that. But just so you know, cosine is going to be our x value, and then sine is going to be our y value. And we don't even need the of x because that's going to complicate it. We don't want to do that. And if you want to think about it in an easy way, x comes before y in the alphabet, c comes before s in the alphabet. So you can just memorize it like that. But the reason I'm introducing that is because I'm about to show you guys the coordinates on the unit circle a much easier way. This is quite literally as easy as 1, 2, 3. Check it out. 1, 2, 3, 1, 2, 3. Then we're going to put a comma between all of these, divide everything by 2. And then we're going to take the square root of everything. So the square root of 1 is just 1, so we don't really need to draw the radical for that. Square root of 2, square root of 2, square root of 3. And those are your basic, those are the first 3 values of the unit circle there. So this one right here in radians, this is just pi over 2. And I don't want you guys to think this is totally unrelated. Like pi is 180 degrees. Let's write that just because I know a lot of people have a hard time grasping that. 2 pi is 360 degrees. And if you want to do the conversion in your head, you could do like 2 pi times 180 divided by pi. Yeah, so this is unit conversion. I think they call it like dimensional analysis in chemistry. I don't really care what you call it, just make sure you got the right things on the bottom. So 2 times 180 gives us 360 degrees. All right, tangent values, we don't even need to know them because we can derive them, but there is an easy trick for it. So tan we know is equal to sine over cosine. So sine over cosine, so if you really want to, like, we'll just start with find the tangent of pi over 6. So the tangent of pi over 6 equals, so we know that tangent is sine over cosine, and we know that our y value is going to be our sine because s comes after c in the alphabet. So let's look at what our y value is. We've got 1/2 for our y value. If you guys remember, when you divide by fractions, we need to keep the first term, change from division to multiplication, and then flip the second term. So root 3 over 2 is now going to be 2 over root 3. Yes, I know, there's a radical in the denominator. That's bad. Oh, yeah, this is just on my YouTube channel. You can watch this anytime afterwards. I make it live, so if you guys want to ask questions while it's going on, you can. But yeah, pretty much all your high school teachers told you that you couldn't put a radical on the bottom, but it really doesn't matter. In math, we just move numbers so they work. So 2 cancels with 2, so we get 1 over root 3. You guys are like, oh, that doesn't look familiar for the tangent value of the unit circle. That's because they like to be fancy. Get rid of the denominator on the bottom. So now we get root 3 over 3. So our tangent value for that is going to give us root 3 over 3. I'm guessing you guys can figure out that root 2 over 2 divided by root 2 over 2 is equal to 1. So we can just, and if anyone needs me to, like, it's just the same thing over the same thing equals 1, you know. 1 whole out of 1 whole is 1 whole. And then this one right here is just square root 3. I can work out the division, but I'm sure you guys would rather me not do that for every value. So now all of these values, right? If we take like a graph, let's just, is this, yeah, this is the camera. So we know that first quadrant is positive, positive for the coordinates. We know the second quadrant is negative, positive. Third quadrant is negative, negative. And then the fourth quadrant is going to be positive, negative. So what that means is that for the coordinates here, all you have to do is reflect it, you know, like, and then just change the signs as is. So like 1/2 root 3 over 2 over here for this next value, it would be negative 1/2 positive root 3 over 2. So it's just based off, the coordinates are just based off the signs. Most people, though, probably don't have trouble with that concept. The concept that most people have trouble with is memorizing the radian values. Lucky for you guys, I happen to have a trick for that one because I did not want to memorize those radian values, so I figured a way to not to. All right, so for this first one, let me clear up some room. Does anybody need me to leave anything up here? You guys can. What am I talking about? You guys can literally rewind and watch this later. Okay, so I'm just getting myself some room so I can kind of write out some general rules, because this right here will be something you probably want to write down, because I don't think they teach it in trigonometry or algebra anymore. Or I don't think that teachers have ever taught it because they just want you guys to blatantly memorize this. I disagree. So let's see. Second quadrant, we'll just abbreviate that with Q2. So the way we find the radian values, right? So let's start with pi over 6 here. So the denominator for these values is always going to stay the same. For root 2, the way we're going to find the numerator is we're going to do this. We're going to say denominator, I'll just write denom, let's see, minus 1 times pi over denominator, because that's not changing. So if you do that, we're going to get our next value here. So what I'm basically saying is 6 minus 1 times pi divided by 6, and that's going to give us 5 over 6 pi. But it's actually going to be down here because we have to reflect the values. Then pi over 3, if we want to do that one, that would be, let's see, denominator minus 1, so that's going to give us 2 pi over 3. Did I not do enough lines for this side? I sure didn't. And then 4 pi over 4 is going to give us 3 pi over 4. Does this right here, does that make sense to everyone? Is there anyone that is having trouble with that? Because this right here, if you know this, you do not need to memorize the unit circle. So if you're having trouble with that concept at all, please let me know now and I'll address it. Okay, I'd say that's been enough time. So next is going to be Q3, which is our third quadrant, all negative. So this one is the same as unit 2, or as quadrant 2, but instead of subtracting 1, we're going to add 1 and then multiply it by pi. And then divide by the denominator. So now 5 pi over 6. So the only thing you really need to know is the denominator. So I just look at the nearest one to reflect it just because it keeps the math easy. So I know that this is over 6. So 6 plus 1 is 7. 7 times pi over 6 for our radian value there. Then we've got 4. So 4 plus 1 is 5. 5 pi over 4. And then we've got, let's see, 3. So 3 plus 1 is 4 pi over 3. So if you know that pi is 180 degrees and that pi over 2 is 90 degrees, then you know that pi plus pi over 2 should be equal to 270 degrees. Because we're taking half of a circle and adding a quarter of a circle to it, so I think that makes sense. So that means that this right here at 270 degrees, our radian value is going to be 3 pi over 2. So now this one right here, quadrant 4, is the only one where the trick gets a little trickier, but it still prevails. So for quadrant 4, what we're going to want to do is Q4 equals denominator times 2, parentheses, close parentheses, minus 1, another set of parentheses, times pi over denominator. So this one I think tends to get the most questions because it's kind of the sloppiest one, but ew, I just do not like how lopsided these lines are. All right, so let's start with pi over 6. So 6 times 2 minus 1 all times pi over 6. So 6 times 2 is 12, minus 1 is 11, times pi, so we've got 11 pi over 6. And the same works for the rest of them, like pi over 4, 4 times 2 is 8, minus 1 is 7. So we get 7 pi over 4. Then we got 3 times 2 is 6, minus 1 is 5, so we get 5 pi over 3. So there you have it. That's your unit circle. We know that if we come back to 0, then we'll get the 2 pi to complete the circle. And no pun intended, we will have come full circle. So the next thing we're going to go over is going to be some basic trig identities, and we'll just call this a short session because I just wanted to make sure that we could introduce you all to some basic topics. But this is trigonometry, logarithms, radicals, algebra. If you know that stuff, like calculus 1 should not be too extremely different. So I'm going to erase this unit circle. I'll leave this side up just in case anyone's writing it down. Okay, so we'll get some trig identities in there. We'll change colors because we've been using purple for a while now. So trig identities, everyone should know this one. Sine squared plus cosine squared equals 1. The next one is tangent squared plus 1 equals secant squared. I think the other one is cotangent squared plus 1 equals cosecant squared. Yeah. So So those are the basic 3 trig identities. You should have those 100% memorized. If you really like math and you just want to go for it, because I don't know, there could be a potential math major in this watching this video, but you can derive these 2 from this first one. Because, like, for example, just a quick one, just so you guys kind of understand that this stuff isn't all separate concepts, but they're closely related ideas. So if we want to get to this one, why don't we just divide this whole thing by cosine squared? Oh yeah, I know I'm blowing some minds right now. So sine squared over cosine squared, that's going to give us tangent squared. Cosine squared over cosine squared, same thing over same thing, so that's going to give us 1. And then 1 over cosine squared, the reciprocal function of cosine squared, which is secant squared. So those are basic trig identities. We should also know, here's some real basic ones that should look very, very familiar, and you should definitely be hitting the books if these don't. So we got oh, that's depressing, that's dead. Okay, so we got secant is equal to 1 over cosine, cosecant equal to 1 over sine, cotangent equals 1 over tan. Or another way to write cotangent is cotangent equals cosine over sine. So I guess the next thing would be some general graph shapes, but I think I'm going to have a little bit of fun instead. So we're going to do the difference quotient. You may have learned this if you took trigonometry. I'm pretty sure they covered the difference quotient in pre-calculus. If they didn't, then it's not pre-calculus. But I'm not about to go on a tangent. So let's think about this. Difference quotient. F x plus h minus f of x over h. That should look very familiar to all of you. This is something we learned probably last year or the prior semester, if you are in this class. But they probably also didn't tell you guys the reasoning for learning said. It's a little hard to see green. Okay, I'll get rid of green. So this is just, I can rewrite this real quick. Sine squared plus cosine squared equals 1. Tan squared plus 1 equals secant squared. And then cotangent squared plus 1 equals cosecant squared. Okay, so where was I? Difference quotient, f of x plus h minus f of x, all divided by h. I'm sure if you took trig last semester, you saw a lot of this, and I'm sure it was the bane of your existence. Well, it's going to continue being the bane of your existence for probably another week or 2. Then you're going to learn a trick that's going to make you just really wish that you hadn't spent all that time doing that, because it's good to know the concept. So if you like conceptual big picture thinking, this is pretty much the only difference between this and a derivative is that a derivative, like I was talking about earlier, we consider as an infinitesimal. So h approaches 0, f of x plus h minus f of x all over h. So a derivative is just what's the word I'm looking for? Oh, a derivative is just a difference quotient with a limit attached to it. So here, I've got a worksheet that I saved from a little while ago. Let me see if I can find a good one of these. Because I know you guys haven't quite been shown a lot of conceptual stuff because this is probably your first higher level mathematics course, but we'll just dive right into it. So limit as h approaches 0 for the difference quotient. So let's say I asked you to find the derivative of, I don't know, let's just say 2x, a very simple linear polynomial. So if we'll, I don't know, d dx of 2x, f of x equals 2x. So the way we do this formula is like this. We do limit h approaches 0. We've got f of x plus h. So we're just going to plug in plus h for x there. So it's now going to be, instead of 2x, it's going to be 2 times x plus h. We will then subtract the original statement, which was 2x. And then we will divide by h. So this probably doesn't look too pretty right now, but with a little simplification, it's not actually that bad. We're going to get 2x plus 2h minus 2x all divided by h. So now we're going to cancel like terms up top. We'll do 2x, negative 2x, because 2 minus 2 is 0, which will just give us 2h over h. That's division, so that will cancel, and we'll get 2, which is indeed the derivative of 2x. Now, I'm feeling a little chaotic, so I'm just going to teach you guys this early on. So when you're doing this difference quotient, you'll have something to look forward to when you finally don't have to do it. But this is called the power rule for differentiation, which is basically just a long way of saying move the exponent somewhere else, and you can get the derivative for any given polynomial. And a polynomial is like 2x, 2x squared. You can have a polynomial expression with like 2x squared plus 3x, anything like that. So let's for this one we'll do f of x equals x squared, just to kind of get the point across a little better. So this is just entirely different. This is its own separate idea right here. But the power rule basically says if f of x equals x to some number a, then the derivative d dx, or we can just say dy dx, because f of x, y, I don't know, is going to be equal to a times x to the a minus 1 power. So the derivative of x squared, we would take x squared, drag that 2 out in front, so then we would get 2 times x, then we would subtract 1 from that 2, so it would just be to the first power. So the derivative of x squared is going to be 2x. If derivative means absolutely nothing to you yet, because you've been in this class for 1 week, then I also have a visual representation, just so you kind of get an idea of what you're doing. I know a lot of you are engineers because there's just a lot of engineers, so you guys might like this if I put it in terms of physics. But I won't strictly do physics because I just don't want to. Okay, so let's see. Some of you may have heard this, instantaneous rate of change. So to put that into more simple terms, let's say we have velocity, right? So we've got a slope of velocity like this, and then the derivative is basically I'll write this out, slope of the slope. So this one right here, this is linear, so we know that the derivative of a constant is going to be 0, because if it's constant, then it does not have instantaneous rate of change. But if we have something a little more intricate, like let's say a parabola, we've got, let's see, I don't know, y equals x squared, something like that. I'm not the best artist, but I'm pretty good at math, so it's okay. So this right here, x squared, as we just said, if f of x is equal to x squared, then the derivative of f of x would be 2x. Which would be something like this. So that's saying if this is acceleration, or if this is velocity, then that's the acceleration. Just kind of a big picture thinking. This is not a great example because this is more of a secant line, but that's what a derivative is going to be, a secant or a tangent line. If you're not taking the derivative at a point, you can think of it as a secant line. If you're just taking the derivative of an expression in all terms of x that is not asking for any definitive values, numerical numbers, like a finalized answer, if the final answer can be simplified into terms of x, then you probably can visualize it as a secant intersection. But if you're asked to say, take the derivative at a given point, I don't know, we'll just say something easy like x equals 1. Then pretend that line's straight, but that would be a tangent line that only intersects at x equals 1. So basically, plain English, this semester, or this summer, I guess, slope of the slope. That is a great visualization for it, a great way to phrase it. Like, you can't go wrong with that. If your professor asks you, or if someone just, I don't know, if a tech student asks you, because they probably would, because they go to Georgia Tech and they want to flex. Now you know the word. Now you know the words they use. Instantaneous rate of change, because that's pretty much exactly word for word what your textbook will say. You can view it as an infinitesimal, but if you're just here to if you just need 1190 slope of the slope, if you want to be in any STEM field, anything that requires numbers, like anything that's related to physics more, to put it into better terms, instantaneous rate of change. And that all comes from the difference quotient when the limit is approaching 0 for h. And the reason we call that an infinitesimal is because that is going to be an infinitely small number, because you can't divide by 0. So infinitesimal, no, don't worry about that yet. Not quite yet. That's going to be more towards the end of the semester. I don't want you guys, don't erase that word from your mind. Just think derivative, instantaneous rate of change, slope of the slope, the difference quotient with the limit as h approaches 0. This should cover most of the fundamentals. If you had any trouble with this video, if you didn't understand a few concepts, feel free to email me or just put a question in the group chat. I'm fairly responsive. I'll be pretty quick. If I'm not home, there's not much I can do about it, but I just wanted to kind of give a quick introduction, say hi, teach you guys some math that you already know, stuff you should know. But I hope that this session was useful. If there's anything you want me to do differently in the future, please feel free to let me know. I understand that some of you may not have access to like high quality internet, anything like that. So if you're in any weird situation, if the virus is causing any trouble with your current educational abilities, feel free to reach out to me. I'm going to be available most of the time. I work from home. Like, I'll pretty much always be available. I'll pretty much always have a question answered in the group chat the same day. Just don't don't ask the same question twice in a row. Like if someone posts the exact same question, you ask the same question immediately after them, I'm going to be a little concerned for you. I won't lie. I don't get it, but don't worry about it, because none of you are going to do that, because I'm sure you guys are all smart. But yeah, that's our SI session. So message me if you have questions, suggestions, comments, concerns, and have a good day. Stay safe, wash your hands. Good session, y'all.